Right, question number 11. Two forces P and Q act on a particle at point O. The force P has magnitude 15 newtons, so let's put that in. And the force Q has magnitude x newtons. The angle between P and Q is 150 degrees, as shown in figure 1. The resultant of P and Q is R newtons. Given that the angle between R and Q is 50 degrees, so R must be somewhere like this, and this is 50 degrees. Find the value of x. Okay, so I can think of two ways of doing this question. So what we can do is look at the horizontal and vertical components of all the three forces that we've got. We've got we've got Q, P, and they net together to give you R. So let's look at P. This angle here is 30 degrees because we know the big angle is 150. I'm going to move the 15 because it's getting in my way. So we're going to move it to there. And so the horizontal component here is going to be 15 cos 30 because it's next to the angle. And the one that's opposite the angle, that's going to be 15 sine 30. And then we know that the resultant is going to be R. Okay, let me just write that one more time. 15 sine 30. Right, the resultant is going to be R. And the horizontal component of R is going to be R cos 50. And the vertical component is going to be R sine 50. And we can see it's going to the right and upwards. Right, so if we resolve horizontally, now horizontally we've got x, we've got minus 15 cos 30, and we know that that nets to R cos 50. So we've got two unknowns, we've got R unknown and x unknown in this equation. Now if we resolve vertically, and we look at upwards as being positive, we can say that, remember the two forces P and Q, they net together to give you R. So Q doesn't have a vertical component. So R's vertical component must come from P's vertical component. And the vertical component of P is 15 sine 30. And that must be equal to R sine 50. Right, this vertical resultant only has one unknown, and so from this we could work out R. And so rearranging, we can say that R is equal to 9.79. Etc. Do not round at this stage, make sure you store that in your calculators. And we're going to sub that R back into the top equation. So sub into this one. We sub it into there, move the 15 cos 30 over, and we can rearrange to say, so 15 cos 30 plus R cos 50. And so x comes to 19.28, etc. And now you can do your rounding because we're finished with this question. It's 19 newtons. Or 19.3 newtons. So we didn't use G in this one. 3 sig figures is usually better. As I mentioned at the start, this has actually got there are two ways of doing this question. So if you want to do it the other way, this involves triangular forces, and I generally don't do triangular forces, but in this question it's not too bad. So triangular forces, how it works is that you make a triangle of forces. It doesn't always have to be a triangle, but there's only three forces in this question. So in this question it will be a triangle. And that was x, and this was 15 newtons. this angle was 150, and then we had our resultant, which was over here, an angle of 50. And so with triangular forces, you basically draw one force, and at the end of that force you draw the second force, and at the end of the second force you draw your third force. And the whole point is, if the particle is in equilibrium, then you should get a triangle. So I'm going to draw Q to start with, just to iterate that, it doesn't matter which one I start with. So that was X newtons going to the right. Now I'm going to draw P. So P was there, and this angle here was 150 degrees, and this was 15 newtons. Okay, and then our resultant was there. Okay, and altogether you can see that we make a triangle, and our resultant is actually going this way. Well, that's R, going in that direction. And this angle, we were told, was 50. Right. Now, knowing that this angle, knowing our angle on the right in yellow there is 150, helpful, that tells us that this angle in here is 30, and we can work out the last remaining angle, and that must be 100. So now what we've got here, if I redraw it, we've got a triangle where we know all three angles, and we also know one of the sides. We know that this is 15. So using sine rule, I could now work out x. So I can say x over sine 100 is equal to 15 over sine 50. Rearrange that and you should get x is equal to 19.28. Just like before. And so the answer is 19.3 newtons. So depending on which way you did it, let's just look at the Mark allocation. We would say that there's going to be a method mark there, a method mark for this one, and to get both right, you'll get an accuracy mark. So there's 3 marks just for doing your resultants in horizontal and vertical directions. And then a mark for getting the R value right, and then a mark for getting the X value right. So those are your 5 marks in the first method. In your second method, because most of the work was in the triangle drawing, these, just getting the sine rule correct, if you got the values in the correct order, then you'd probably get 3 marks for doing that, and then a method mark and an accuracy mark for just solving. But as I say, the hard work is in doing the sketch for that, if you use that method there. Okay, so that's question number 11.